in exercise 1 about 52 MCQs are there related to the metals. Exercise 2 is about the extraction of the metal, how we can extract. You can use a mic or you can also use a chat to state the answer. So zinc is extracted from an ore which is known as a zinc blend, which is zinc sulfide, which mainly consists of zinc sulfide. Because there are other impurity, mainly zinc sulfide is there. So zinc sulfide in the ore is first converted into zinc oxide. How zinc oxide is made from zinc sulfide? How we can convert the zinc sulfide into zinc oxide?
So, Mr. by roasting in the air.
By roasting or heating in air. Or by reacting with oxygen is correct. By heating in air is also correct. Then the equation for this conversion, zinc sulfide is reacting with oxygen, so it will form zinc oxide plus sulfur dioxide. Then the equation must be balanced. So we start balancing with oxygen followed by hydrogen. So we have here we don't have like hydrogen, we have oxygen. So we can balance with oxygen. So on the right hand side, 1 plus 2, 3 oxygen. On the left hand side, only 2. So the side where we have less, there we start. So we start with 2. 2 multiplied by 2 is 4. We can react with the coke, but the idea is that reaction with the coke is normally at a high temperature, much higher temperature. Like you need a very high temperature for that. So if I put 2, oxygen is 4 here, but if I put 2, oxygen is 4. But zinc, when we try to balance, so this is 2. So we put 2 here, then we have to change the oxygen, so it will be 3. So 2 ZNO, ZNS plus 3O2 gives 2 ZNO plus 2 SO2. Now here coke is not added. I'm answering a question like as he asked, we can also react with a coke, but the problem with the coke, it should be a very high temperature at the beginning. So we normally don't use a coke first. We convert into zinc oxide, and then zinc oxide, we extract the zinc from it. Then the zinc oxide is converted into zinc. Zinc oxide and a coke are fed into a furnace. A hot air is blown into the bottom of the furnace. The zinc melting point is 420 and the boiling point is 907. Temperature of the furnace is over 1000. Explain how zinc oxide is converted into zinc. Your answer should include detail how the heat is produced and equations for all reactions you describe. So first, how heat is produced. Carbon react with oxygen, gives off carbon dioxide. The reaction is exothermic, which produce heat. That is one thing. Then what will happen? The carbon dioxide react with more carbon in the furnace, produce carbon monoxide. And carbon monoxide is a reducing agent. Means it has a capability to remove oxygen from the compound. And zinc oxide react with carbon monoxide to form zinc and carbon dioxide. And why the zinc produced inside the furnace is the gas. So you can see the melting point is 420 and the boiling point is 907. And the temperature is above the boiling point. That's why. So the temperature of the furnace. So temperature of this furnace is above the boiling point of zinc. That's why the zinc which is produced here is not in a solid state. It is in a molten state. Is it clear, this one?
Yes, sir, clear.
state the name of the physical change when a gaseous zinc convert into molten zinc. Like a gas turned into liquid, what we call?
Condensation.
So we call that as a condensation. Rusting of a steel can be prevented by coating a steel with a layer of a zinc. Explain in terms of electron transfer why steel does not rust even a layer of a zinc is scratched, so that the steel is exposed to air and water. So the same question we have discussed, like if we have a piece of iron that is having a layer of zinc that is galvanizing or galvanized, and what happened in the atmosphere, like a layer of the zinc is a scratch, but still it does not rust. So what is the reason for that? And it's of 4 marks. So how you score all the 4 marks for this? 1 mark when you mention zinc is more reactive than iron. That will give you 1 mark. This is the first mark you will score whenever you mention zinc is more reactive than iron. The second mark, because the more reactive metal, it lose electron easily. So in this case, the zinc will lose electron first, or zinc loses electron easily. That is the second mark. And as a result, what will happen? Electron transfer, because electron always transfer from more reactive surface to less reactive surface. So electron transfer from zinc surface to iron, or you can also say to oxygen or to water, because it's reacting. So therefore the iron cannot lose electron, because it's already like lot of electrons are on the iron surface, so it cannot lose its own electron. So iron cannot lose or does not lose electron. Or oxidized to form the rust, or you can say iron 3 oxide. So this is how you score the 4 marks for this question. The 4 points. Number 1, zinc is more reactive than a piece of iron. Zinc loses electron easily or first. Electron transfer from zinc to iron or to water to oxygen, and therefore iron cannot lose electron. Iron should lose electron to rust, but because all the electrons are coming to iron surface, so it's not able to lose its electron. That's how the iron is prevented from rusting. Can we say zinc has a tendency? That's right. You can also say zinc has a greater tendency to form an ion. Both have the tendency to form an ion, positive ion, and not only ion, it should be a complete sentence forming a positive ion. You can say that as well. Zinc has greater tendency to form a positive ion than iron. That is also correct. So don't forget to mention these points whenever, even sometime in place of zinc, they place a magnesium. Same answer is there. Only thing what we'll do, we'll just make a like we'll, instead of zinc, we'll write magnesium here. Any more reactive metal is used other than iron, so the answer remains the same. It won't make difference. Then another question, the diagram shows a blast furnace that is used for extraction of iron. You can see 4 equations are given. The following equation represent the reaction that take place in the blast furnace. The question is, You can use a screen annotation to answer this. You can use letter A, B, C, D, or E. Which reaction is used to increase the temperature in the blast furnace? That is A, correct? Because this is highly exothermic, carbon react with oxygen, give carbon dioxide. Which reaction is its example of thermal decomposition? One reactant, more product. That's B, correct? In which reaction carbon dioxide is oxidized and reduced? Like oxygen is added and removed. So you can see here, like for carbon dioxide, it become carbon monoxide, and carbon become like carbon dioxide become carbon monoxide. So oxygen is reduced, decreased. So reduce, and here it's oxidized. So D will be the right answer. And which equation shows a removal of impurity from iron? Not E. E is not right because oxygen is not the impurity. Impurity means any other compound. So E is not the right answer for this. C is the right answer. So the impurity which is present here is not oxygen. The impurity is the silicon oxide. Is the impurity. For which reaction the silicon oxide is removed? That is in C. And which equation show acidic react with a basic? That is also C. So the last two, the answer is C. So it's A, B, D, C, and C. So impurity is silicon oxide, not iron, oxygen here. Oxygen is the, like it's forming a compound with iron. Use the diagram of the blast furnace to help your answer these questions. What entered at the blast furnace? At X, what is entered?
hot air.
Hot air. And what is leaving at Y? What is leaving at Y?
Molten iron.
Molten iron. If there was another arrow, Z was there, then what should be your answer?
Molten slag.
Slag. So, but it's not given Z, so it's we don't have to write. So it will be at X, it's hot air, and Y it is a molten iron. Then name two gases that leave the blast furnace. Which gases will leave this blast furnace here? The waste gases. Can you name?
Carbon monoxide and dioxide.
Carbon monoxide, carbon dioxide, even nitrogen is acceptable because you're adding air. Air contain nitrogen, it contain oxygen, it contain carbon dioxide and other inert gases. So first carbon react with oxygen, give carbon dioxide. Carbon dioxide react with more carbon, give carbon monoxide, and there are unreacted nitrogen. So it is acceptable carbon monoxide, carbon dioxide, or and nitrogen. Any, but you have to name any two. So you can mention carbon dioxide and carbon monoxide here. So CO, but its name, don't write a formula, don't write CO and CO2, that is not correct. Because you have to name them, so carbon mono and carbon dioxide. As you can see, we are increasing the percentage of a carbon, it will become less malleable or rigid. Describe how the malleability of iron changes as the percentage increase. So what happened to malleability? The malleability decreases as the percentage of the carbon is increasing. Iron obtained from the blast furnace contain high level carbon. Explain how the amount of carbon in iron can be decreased. That's is a basic oxygen furnace. For that purpose, we'll use a basic oxygen furnace and below the oxygen, which react with carbon to give carbon dioxide. So we will use the basic oxygen furnace and we'll blow the oxygen, which react with carbon to give carbon dioxide. So these are like first two questions from exercise 2, the metal and the extraction, the topic metal and its extraction. Next session we'll do more questions from this exercise. Any question or a doubt related to the session today?